Well, welcome back, everybody. Thank you for joining us in this bonus reel continued conversation about the cross-dimensional education challenges in smart manufacturing. So we're back behind the scenes here, continuing the dialogue, and I know we have plenty still to discuss. So Conrad, you want to continue the conversation?
Yeah, while we were just ending over there, we had a question that came in for you, Raghu. Just curious, how did you integrate the ideas into an undergraduate course? Was it via modules, separate courses, or did you infuse it into existing courses?
So so it's actually both. We are creating new courses and also infusing the knowledge into existing courses.
Yeah.
So that's what we are working on right now, and still it's a very much a work in progress, and we are getting a lot of insights from our industry partners and also some of the technology partners that we are working with.
Yeah, why don't you give us a little idea of the time frame? You mentioned a lot of things are going on, new programs are being developed. Can you give us a little idea of where you're at in that process and who's involved?
Yes. So we actually started this process about almost about a year ago. We actually recruited industries and also technology partners who are, have very high level of maturity index when you talk about smart manufacturing. So we, pretty much handpicked, who we want to bring to the table to provide some guidance, because if you look, there are no benchmarks in the United States or pretty much anywhere in the world as to who's doing a smart manufacturing. We brought a lot of players to the table, and like I said, this work actually started about a year ago, and then late last fall we arrived at a framework which we felt very comfortable with. And in the spring, this spring, what we are working on is doing the mapping. How do we map the 3 core strategies and also the 9 core technologies that is transforming the industrial production, as you may call it, and how do we overlay that into an existing traditional manufacturing curriculum? So the outcome we anticipate is, we are going to renew a lot of courses, upgrade a lot of courses, and also will integrate some brand new courses. And there's also even talks about how perhaps we can leverage a minor that is being developed on the Purdue campus, that is being developed by the in data science, I would say. So that way we will reduce our burden of delivering the entire curriculum by ourselves. So we hope to have most of the curriculum material completed by end of December this year, and take it through the approval process beginning of spring 2021. And hopefully we will have a program ready for a soft launch in August of 2021.
Two quick questions that come to my mind, and don't have to take them both at the same time. I guess one would be, you talk about Germany, talk about other parts of the world. So how does this compare? I guess how you told them we'll be back and you'll be envious of what we're doing. How long till we get to that point? And then a separate thread we can park and lot for a little later is once the degree program, the undergraduate degree program is ready. Just like to kick around the ideas of how attractive you think it's going to be with future students that are coming in. But maybe you could go first and talk about the Germany piece. Or the European.
Yes. So I had a lot of interactions with schools in Germany, and also Purdue belongs to the International Association of Learning Factories. These are mostly universities that have very, very strong manufacturing programs. And so we became a member of that. In fact, the membership is by invitation only. So, you have to show a lot of progress as to what you're doing in the realm of smart manufacturing to be accepted into that group. So we are now part of the group, and one of the reasons we joined that group is so that we can learn what many of the top German universities are doing in the realm of manufacturing. And like I mentioned, a lot of what they do is in the graduate level. So they are actually looking at us very closely as far as what are we going to be able to achieve at the undergraduate level. And so, and which is what we are hoping to have accomplished in about a year from now, that we can then showcase, not just to Germany, but, I'm really looking at what we can do to help democratize some of this, the best practices that we have learned as far as creating an undergraduate program in the US. We hope that Georgia Tech and anybody, in fact, anybody will take on a program like what we are doing, so that we start moving away from the manufacturing programs that are traditionally that are in the universities right now from the industry 3.0 era. So my goal is that more universities will look at us in seeing how we can now transform this into the 4.0 era. Because, not to say that the 3.0 is not good anymore, it's just that we need to add more bells and whistles, as you may call it. So that is what we are trying to do at Purdue.
Well, it's fantastic. You talked before, and Conrad, jump in and take over. I keep asking questions, but this just spurs to me the thought you talked earlier about citizen technologists. One of the things that I believe in, and we've talked about a good bit, is the fact that there's a whole bunch of tech savviness, or just the baseline of where people are, where the younger generation is today with their understanding and comfort with technology, is such a barrier obliterated that they don't bring with them, that has been in our way, so that there isn't this silo of, oh, now I got to go learn this thing. It's, well, this is how I operate, right? I'm used to having these devices and these technologies and this access, and so I'm just gonna jump in and share and go problem solve, which engineers do, right? Manufacturers do. I'm gonna go problem solve using modern technologies.
So Mike, that is a very interesting observation, because we are dealing with digital natives coming into universities these days. Unlike when I went to school, where looking at a computer was a scary thing, right? Now, looking at students these days, they are extremely savvy with technology, and you add to that the fact that companies like Microsoft, Google, Amazon have really democratized computing to the point where you really do not have to be an expert.
Right.
So, which is where the idea of the citizen data scientist is coming from.
Yep.
So our hope is that the graduates that we are preparing, we will really, take the skills and hone in their tech savvy skills, and put some computing on that, and put some IT on that.
Now, because when I use the term citizen data science, I don't think of somebody going through a 4-year degree program.
Not at all. Not
okay,
at all.
All right.
So
what? Yeah. Okay. So if you can talk to us about that, how you position that in the undergraduate level, and how do you take it beyond undergraduate student studies?
Yeah. So if you ask me the question, all right, at the end of the day, someone coming out of this Purdue program, what jobs are they going to take in industry? My answer is they are still going to take the job of a manufacturing engineer. Okay. But the citizen data scientist is a role that they will assume along with their primary job function as an engineer. That's the way we look at it. So this is something, like I mentioned earlier, we are overlaying, by cross-training them with the IT skill, the data skills, and the computing skills, so that they can now use all this knowledge and bring value to the manufacturing operations that are, as you can see on this slide here, how do we take the digitized systems, the smart systems, and the connected systems to create value in manufacturing?
So do you think, though, that as you create that layer of the citizen data scientist, what that program looks like, that it could be applied to somebody who doesn't have an engineering degree to start with?
Yes, you can. We feel we can. In fact, this is where we go into the workforce education. What do we do with the people who are out there, the engineers who are out there, and the people who may not be engineers who are out there? So again, I go back to the fact that, the democratization of computing. Take, for example, artificial intelligence and machine learning. In 1995, I did AI, I did machine learning. But if you look at my dissertation that I wrote, there's not one single page without half of the page filled with mathematical formulas. So our intent is not to create a data scientist. Our intent is, the citizen data scientist is not an expert in data science. However, they will know how to use the tools and be able to do some basic modeling and use that to solve problems. Now, if they, obviously a citizen data scientist does not replace the role of a data scientist, because you still need to have the data scientist to do the heavy lifting with the modeling, with the statistics and all of that. But what we need more of today is, is the more of the citizen data scientist type who can very quickly turn on a dime and get to work trying to solve problems in industry.
That is so spot on. I'm so happy to hear you say that, because for years we've had conversations about data and information and metrics and analytics and now intelligence, right? In this scaling, and a lot of times people will say to you, I want this, manufacturing intelligence solutions, or I want this statistical process control type of solution. And you get in, and really they just want some basic reports, right?
Absolutely.
They're coming in with some expectation of a maturity level, 4.0, 3.0, whatever the level is. But the reality is they just want to solve some immediate problems, no matter what it's called. So I'm glad to hear, and we actually touched on this in our last 6 Degrees webcast as well, that the answer isn't data scientists to the rescue, and we all have to wait until there are enough data scientists around. But the notion that you just talked about of using data science at a democratized level to solve problems is brilliant, spot on.
Yeah, and so in LinkedIn, I looked in LinkedIn. So the highest demand for, across the country in the United States right now is for data scientists, and that demand is growing by at least 30% every year. And let's face it, the U.S. is not producing enough data scientists to go and be in every manufacturing facility, whether it's small, medium, or large enterprise. So there is a big demand for these data scientists. So the ability for any company, particularly a manufacturing company, to be able to attract them, pay them very high salaries, and let alone retain them is going to be a huge challenge.
I think, I'm sorry, Conrad, I'm hogging the conversation.
Go for it.
One thing, and then I'll shut up. I think one of the things that, so I'm an engineer, been in manufacturing for 30 years. I mean, the problem solving nature, like people that work in manufacturing are problem solvers, right? They want to solve problems. And so it just inspires me to think about all the problems we can solve with these new technologies, with the data unlocked from manufacturing. You can look at report after report after report that says in the whole IoT landscape, the biggest opportunity to drive value is in manufacturing. And you're talking about it in this level, like at the plant level, at the device level, at the systems level, right? And so I hope that it is inspiring for the next generation of problem solvers to say, I'm going to solve big problems, and that's what's going to pull me to engineering or going to pull me into manufacturing versus going into other industries. Because we've watched for decades personally people that came in with an IT or a networking or a, you know, a software background and just burned out in manufacturing because it was too demanding an environment and too many barriers in the way, and, you know, ended up going over to other industries. So I certainly hope that that this gets democratized the way that you're talking about, and it inspires people to come and pour into manufacturing.
Yeah, and in fact, you know, I would say companies like Microsoft, you know, I really can't speak for the others, but, you know, we work very closely with Microsoft. So companies like Microsoft right now is creating intelligent edge devices. So these are devices that's got, you know, so these are really smart sensors. So not only you have the connectivity built into these devices, you also have the intelligence built into these devices. So they call them intelligent edge devices. So there is skepticism about going to the cloud. So rather than going to the cloud, because many manufacturers are afraid of their data actually residing in the cloud, because there are some concerns as to who, once the data goes to the cloud, who does the data belongs to. So to overcome all of that, something that we are looking at developing as part of our curriculum is how can we introduce intelligent edge devices so that without going into the cloud, you can actually leverage and deploy smart solutions right at the edge in manufacturing without going into the cloud. Now, obviously, you get more capabilities by going into the cloud, but you know, if you're just looking at some quick and dirty solution on something you want to do very quickly, many of these intelligent edge devices have built-in AI and machine learning in them.
Mm-hmm.
That's wonderful.
Yeah.
I want to make sure that I was wondering, because we're talking a lot of topics that some might see as computer science, and I'm wondering, students that are coming at it from that point of view, more interested on the computer side, are those departments and looking to also offer like a little bit of a citizen manufacturer or something, you know, like a little overlay on the other side? Is that going both ways?
Yeah, so that's yet to be seen. We are taking the
Okay.
lead on Purdue campus right now,
Okay.
particularly on the manufacturing side. But we are seeing a lot of data science going into agriculture on Purdue because, you know, a lot of people don't think of Purdue as being an ag-based campus. We are very much an ag-based as much as we are an engineering-based campus. So there's a lot of data science that's going into agriculture. So they're one of the early adopters of data science into their programs. And they're doing this at the undergraduate level. So, and they too are working with companies like Microsoft, similar to what we are doing. So, you know, so we are, you know, we are not quite the trailblazers on Purdue campus, at least. So we got some partners in crime who are working on similar things. So, but we are also trying to see, you know, how we can leverage each other's knowledge so that we can really, you know, fine tune how we package and deliver this to undergraduates.
Okay. So I want to remind the listeners, if you're in academia or you know, a Microsoft or another vendor that's very interested in these topics, that the CESMII ecosystem is a place to have that conversation, and we definitely want to be part of that bridge. We have a great ecosystem of innovation centers, learning centers, and great partnerships with universities. So we want to help connect people. So feel free to reach out to us via our LinkedIn group, our email. Anyway, if you want us to connect you with Purdue and facilitate some of these conversations. Yep. And Raghu, do you have a call to action you want to share with the audience?
So whatever we are creating, we'll be glad. Whatever we are creating at Purdue, you know, our hope is that, you know, this is not going to be a trade secret for us. We are not in the business of keeping things secret. You know, we are a public institution. We want to share it widely, as widely as we would like with everybody. So if CESMII is a platform that we can do it, we would very gladly be a part of that platform so that we can democratize what we are trying to build here at Purdue.
That's perfect. Yep, and that is what we are here for. So we appreciate that very much. Well, gentlemen, we've essentially done double duty. This session's almost as long as the first session. So I suggest we wrap it up unless there are any other final thoughts here. Any other points to raise?
Oh, I would also, there were some questions about, if I may, are we looking at graduate education? Absolutely, yes. In fact, we are launching a graduate program this fall at Purdue in collaboration with another university in Germany.
Oh, okay.
Yes, so it's actually a dual degree program. So a Purdue student who is going to be joining this program will get a degree from Purdue and also a degree from Germany. Now, the reason we are collaborating with them is they have a little more bandwidth and also a little more experience in that space. And also that allows us to focus more on the undergraduate education.
Excellent. Well, I can tell you, we've seen over the last handful of years, and it's exciting to see the speed and progress that the university systems and the academic community are making overall. And I think to Conrad's point, the role that we can play as CESMII to help reduce friction and overlap and drive commonality of definitions and terms, and that's really what we want to make sure that we're driving. So appreciate what you are doing individually, what your university is doing, and then more broadly to the entire academic system here within the U.S. So, Conrad, you want to close us out? Any final words?
That's it. Yeah, engage with us. Continue the conversation online. We plan to have more educators, more integrators, manufacturers, all kinds of different perspectives on smart manufacturing. And this is all coming together, and you should be a part of it.
Absolutely. All right. Well, thank you all. Take care. Have a great day.
Thank you.